Good afternoon and welcome to this first English video on my YouTube channel. For all my regular viewers who are now wondering why is this guy suddenly speaking English with a rather bad German accent, well, it's down to the topic that I'm going to cover today, and this is this little HextrudORT CNC version. I already uploaded some time-lapse videos of those parts, and they're going quite strong on YouTube in my secondary channel at the moment. And I think they are, contrary to my normal channel and my normal videos, the majority of people that are watching those are not German, and hopefully most of them are at last English speaking. So I decided to make the video about this extruder in two versions, one German and one English. At the moment, obviously, you're watching the English version, so if you want to have a look at the German version because you don't want to listen to me talking English for the next 30 minutes, well, feel free to hop over to the German version of this video. For everybody else, welcome to my YouTube channel. As I said, this is the first video in English. In the past I covered everything in German. And as a starting point, first of all, a little disclaimer. I'm in no way affiliated with Simon, with the Vz-HextrudORT team, with FCD Racing and Mellow. I'm totally independent. I've never talked to them in person. I'm a bit active on the Vz-HextrudORT Discord server, and I think Simon commented on one or two of my posts and videos, so thanks for that. But besides this, I have nothing to do with them. I simply copied what they are doing for my own purpose here. To give a bit of context what I'm normally doing on my YouTube channel, this channel is typically about DIY CNC machining. I'm down in my basement. I have a self-built DIY CNC machine here on my side. This machine is doing all the milling that you're going to see in this video and in my other videos. So personally, I have no background in machining at all. On my real job, I'm an IT person, and all the CNC machining is completely self-taught, YouTube University, so don't expect industrial quality out of my parts. And I'm sure there are tons of ways to do this better and faster, but well, this is a hobby for me and I'm just sharing what I'm doing. So always keep this in mind when looking at my videos. If you want to have a bit more background information about my CNC machine, have a look at my YouTube channel. For you, unfortunately, they are all in German. This is my main audience, simply because that's my native language, and yeah, it's a bit easier to talk in your native language when you're doing stuff that you have basically no real experience with, and there's enough brain power going into building stuff, and I don't have enough capacity left to speak a foreign language as well, so that's why I'm sticking with German. But for those videos regarding the 3D printing stuff, I thought it might be interesting for a wider audience, so I'm giving English a try here. So bear with me and have a lot of fun with this video. Yeah, the topic of today will be this little guy. This is my take on a CNC version of the Vz-HextrudORT extruder. I'm currently thinking about building a new 3D printer, as my current one is now 6 or 7 years old. And yeah, I came across the Vz-HextrudORT, which looked really interesting to me due to all the CNC parts. So, well, as I'm doing mostly CNC machining here in my free time, this became quite interesting. So I decided to give it a go and started out with the extruder part, because this is something that I can use already on my current printer. And well, if this is going good, well, the next step will most likely be building a full Vz-HextrudORT printer, of course with CNC parts, done here in my basement. Yeah, so for starting, I will turn this camera around and we'll have a look in detail at this extruder. So this is the assembled version of this extruder. It's currently missing the motor in the back and of course all the hot end part down here. Simply because I only have one motor at the moment, and the hot end parts I only made one up to now. This is the second extruder I made, and the rest of the stuff is currently mounted already on my printer. if you look at it and compare it to the original version that you find online, this backplate will look a bit strange. This is because I needed to modify it a bit to fit it my printer, because the design differs significantly from the Vz-bot. So this part needs to be changed if I want to later mount this on a Vz-bot. But luckily this backplate is by far the easiest part of the whole assembly. So let's take it apart and have a closer look at it. So the whole assembly consists of 4 parts that needs to be machined, and then of course the hardware parts. Those are from the BMG extruder. So those are sourced from AliExpress or wherever you want to source your part. So no need to machine those. So this leaves us with those 4 parts that needs to be done. Let's start with the easy one. This is the backplate. As I said, it looks a bit different than the one you're most likely used to, due to the fact that I need to mount it on my printer. Here a short video on how this looks on the printers. I basically needed to raise the motor up a bit to avoid it to collide with the X carriage. So that's why the backplate is looking as it is. In terms of CNC machining, this part is rather straightforward. It can be done from one side, so no fancy stuff here. I'm using a blue tape method to hold this raw material here. So it's nothing more than just take some blue painter's tape, putting it down on your machine bed, putting it on the underside of your raw material, and then taking some super glue to stick it together. And this gives you enough holding force for rather light machining. You can't hog material out there like crazy, but with this small end mills that I'm using here, this is quite okay. And yeah, in the end, if I turn it around here, the finished part, there's no need to deburr those. They're coming out fine, so no post-processing from the second side, just a one-sided part. In order of complexity, the next part is this front cover. This is a bit more complex in terms of operations, because you need to do 2 sides. So I started with this side up, did the holes and the hole for the bearing here, because those should be aligned properly together. So I started out with this, then flipped it around, put it in soft jaws, and did the second side. But in the end, rather straightforward, nothing too complex. The third part is the tension arm. In itself, it's not that hard. I made my life a bit more challenging here, because I wanted to do it on the 4th axis in a real one and done operation. And in the end I succeeded, but in the post I killed an end mill, simply because I decided it would be a good idea to hold it like this, cut away everything, and then take my end mill and walk around like this. And it turns out that there's 2 mm of aluminum back here is not strong enough to hold it if I cut it with an end mill from here. So here's a video of what's happened. Basically, the end mill caught on the material and snapped. And this was the time when buying the whole extruder would have been cheaper than making it myself. But well, that's happened when you're doing CNC machining in your basement. You break a lot of stuff. But in the end, I got a good part, and it's really one and done. So only a small mark up here was left that I need to file down, and I did this by hand, and then I had a good part. The really complex part is this main body, and a big challenge here is that you need to hit it from 5 sides in total. So starting out with this side, you need to hit every part here. You flip it over, you have holes here that you need to make. Turn it again, all this back side, and then the upper side. And finally, you're left with this little hole and the M3 thread here. So this is your 5th side. Again, I decided to do this on the 4th axis. simply because this reduces the amount of operations significantly, because I can change my orientation anytime I want to. In the end, I was left with a part that had a cutoff over here in this area, and I made myself a mounting plate, this one, put this part on here, screwed it down with some screws like this, and then went around with an end mill over here to clean up this cutoff area. In a second operation, and then in a third operation, I drilled this hole and tapped it, and then this part was done as well. Then next up, let's have a quick look at Fusion, and after this we'll go through the time-lapse videos together and I will do some explaining there. Yeah, like with 3D printing and CNC machining, nothing goes without having a 3D model of what you want to make. Unfortunately, the model for the CNCed version of the extruder is not publicly available. I somehow get why they're doing this, but to be honest, making the 3D model was more or less the easy part. You can get the model of the 3D printed version, so there you can take all your critical dimensions, the hole locations, the bearing locations and all this, and then strip it down to what you need or what you think you need for machining. So between the 3D printed version that I had here and having a look at the CNCed version on GitHub, I was able to get this done quite fast, I think one evening, and the model basically was done. On the Discord there seems to be a gentleman's agreement in place to not make re-engineered CNC files available, so I will keep this file to myself. If you want to make one yourself, just go through the short effort to make the model. As I said, the model itself is really not the hard part. The hard part comes when having a look at the cam. So the backplate itself, to be honest, nothing fancy, just 2.5D machining. The real trick with the blue tape method is to keep as much contact area between your part and the blue tape as long as possible. So I left a small area here, it's just 1/10 of a millimeter material till the end, and with the last cut I went around the part and freed it, and by this I had a good holding force all the time. That's really it for the blue tape method. It's quite straightforward, a bit similar to vacuum work holding, but has a bit stronger holding force in small parts. With the tension arm, the challenge was, as I said, basically to get it done as a one and done on the fourth axis. With the fourth axis, the number of operations simply add up like hell, because you need to hit it from every side. But it wasn't too bad for the tension arm. The main body itself, as I said, was the real challenge. And if I'm having a look at this, the number of operations, how many do I have here? Yeah, what's telling me 43 operations, and I think something around 11 tools. On my machine, tool change takes around 50 seconds, so simply tool changing was about 10 to 11 minutes, because I'm calling some tools multiple times. So the 28 minutes Fusion is telling me here is a bit optimistic. It's more like 35-40 minutes. So this really takes some time, and this approach is totally not feasible for mass production. So it's really an on-off operation. Cleaning up the part in the second op, quite straightforward, just a contour here and drilling the hole and tapping it in the last operation. Again, quite straightforward, not much here, 3 operations, 3 tools. Again, spending more time tool changing than in the actual cut, but that's how it goes on a hobby machine. The front cover, as I said, 2 operations, not much, quite straightforward. facing, adaptive, flat contour, and some drilling, and that's it, and flipping it over and doing the same on the other side. So here again, nothing fancy. And now let's have a quick look at the time-lapse videos of each part, and I will highlight some other stuff there. Yeah, let's start with the backplate again. As I said, I'm holding the raw material with the so-called blue tape method. You basically put down blue tape, this is in my case Scotch 2090. You put it down on your machine bed, put a layer on the underside of your raw material, and then stick this together with super glue, basically creating a double-sided tape. The benefit compared to double-sided tape is simply you have the possibility to really stick it down to the parts. If you use double-sided tape, you are able to stick it down to one side, and then when you try to press it either to your raw material or to your machine bed, it typically gets some air bubbles, and you're not getting as good holding force as with this method, because the super glue fills everything, and then you have a good bond in all directions. The main material removal here is done with a 2-flute 4mm Kugelumlaufspindeln end mill, and it leaves quite nasty surface finish while roughing. I later switched it over to a 3-flute, which has a significantly better surface finish. And as you're seeing, I removed basically everything beside a small area on the side, and this gives me enough holding force for all the sequential operations like thread milling. And the last operation then cuts it free. And now we are already doing the front parts. The surface finish here is much better because here I'm using the 3-flute 4mm, which is significantly better in terms of surface finish. The small parts are done with a 2mm end mill, and then just some chamfers. Then it's up to making the soft jaws. I'm using a 2mm end mill here again, simply because there's some small areas where I need to have the small radius. Luckily I need to do this only once and can reuse those soft jaw for how many parts I think I need to make. And well, this was quite straightforward. And then second side, just facing it, removing material and adding some chamfers. And the part is done. Yeah, now for the tension arm. On the first axis I always start with bringing the stock to size with a big face mill, because I always have too large of stock material. And now I try to basically remove as new material as I can get away with still being able to hit the areas that I want to hit in this operation. So I'm leaving a big chunk of material left in the middle to give it some kind of stability, and only after I've done the sides I start to really remove material from the center. Fusion is not as easy to control where to remove material, so it's a bit of a tricky situation. As you see here, I'm starting in the middle. It would have been better to start from the left, but well, Fusion simply refused to start from the left, and it was somewhat okay here, but not ideal, but it was working. So as long as I left this big chunk of material on the right side, right till the end, and I was fine. And so now I have everything done on the left side, and I can start to remove the last material here. And now I can come in and do the last chamfers and then cut it off. For the main body, I mainly use a similar approach, first facing everything to bring it on size. During the drilling operation, if you look closely on the vise, you might not see it that good in the time lapse. If you have a look at the real-time footage, you see that the whole assembly of the wires is dipping a bit up and down when drilling. So the whole construction is not perfectly rigid, but I think for self-built fourth axis it's quite okay. Again, I'm doing most of the part here with a 4mm starting, and now I'm switching to a 6mm end mill simply because I need the flute length for the main material removal rate. I'm definitely on the conservative side here in terms of material removal, simply because the fourth axis is not that rigid, and the whole setup with the raw material sticking out that much needs to be taken into account. That's why this part, removing the main part of the material, takes some time, and Fusion somehow in the latest versions adds a lot of air cutting where it really didn't need to cut anything. It's a bit frustrating, but as I'm doing only a small number of parts here, I don't really care, and it's not worth spending 10 minutes in CAM to get 1 minute of runtime. And the chamfer end mill is sticking out quite long here because I need the clearance with the wires on the right side. Yeah, and that's all that needs to be done on the fourth axis, and as you can see, it can be removed quite easily from the cutoff. And now all that's left is cleaning up this cutoff area. This is a quick contour here on the holding block, and then everything is cleaned up and ready to go for the last operation. And then for the last operation, it's really just drilling the hole, putting a small chamfer on top of it, and then cutting the M3 threads. Thread milling always takes a bit of time on the machine, simply because you need to interpolate all the threads. And for M3 threads I need to go 2 rounds here, so this operation basically takes the longest of the 3, and I think it's the only one that's indeed cutting longer than taking for the tool change. And that's it. Yeah, so now you've basically got the fast forward version on how I made this thing. As I said, it's a bit time consuming, and to be honest, I have no idea how Mero is able to sell this stuff for that cheap. Just the machining time, I would be really interesting to see how they're doing it, because they need to have a much faster way, and yeah, otherwise they wouldn't be able to sell it for that price. Material wise, it's not really much, but the time on the machine, and this really sucks. Yeah, I hope you found this somewhat interesting. If this video goes well, I might think about doing more stuff in English, especially for the 3D printing stuff. As I said, I'm planning to build a Vz-bot with CNC machine parts, and there will be for sure some videos machining the parts. Yeah, if you want to see those in English as well, ensure that this video gets enough hits, and I will go through the effort and make every video twice, so that my German audience and the English speaking audience are both happy. Yeah, so that's it for today. Thank you for your time, thanks for watching, have a nice evening, and see you next time. Bye bye.